Welcome to this second quantitative analysis flipped lesson. This one's all about how we calculate the concentration of a solution in chemistry. In chemistry, when we calculate the concentration of a solution, we need to know how much of the solute you put in there and how much of the solvent is in there as well. Now when you look at a bottle of acid in the lab, often on the label we might just have 1.0 m. Now what that m stands for is moles per litre. And it can be written like this, moles per litre, or the more modern way of writing it would be moles with a litre to the power of -1, which means the same thing. So the formula for calculating moles per litre is this one here. A memory jog for it would be cats equal knocked over vases. And we can put that into a triangle with cats equals knocked over vases. Now the N is for Nigel, which is measured in. That's right, moles. The C is your, what do you think? Yep, concentration, measured in moles per litre. And the volume is the big V, and that's always got to be in litres. So whenever you're given mils, we have to turn them into litres by dividing by 1,000. Okay, because there's 1,000 mils in 1 litre, isn't there? Okay. So here's a typical question. What concentration is the solution when 2 moles of hydrochloric acid is dissolved in 50 mils of water? So the key things in this that we have been provided with is they've told us moles, so we know from this our N, and they've told us 50 mils, which is our V. So first you need to convert those mils to litres, so we want 50 mils divided by 1,000. Okay. You can do this by throwing that into your calculator, or simply going 50 mils, it's got a decimal point afterwards. To divide by 1,000, we just move that decimal place over to the left 3 places. So instead of 50, now we've got 0.050 litres. That would be 3 significant figures, 0.050. So we know our N, we know our V, we put it into the cats equals knocked over vases equation. So we have 2 divided by 0.050 equals the answer of 40 moles per litre. I'm sorry, I said that was 3 significant figures. It's not, is it? This would be 3 significant figures, because the first significant figure is the 5, and then you've got 2 zeros after it. Usually with these calculations we worry about the last number being 3 significant figures. So instead of 40 moles per litre, we want 40.0 moles per litre. Okay, so that's 3 sig figs. Sometimes instead of telling you how many moles that you have in a volume, they could give you the grams that you've got in a volume. So before you can work out the moles per litre, you've first got to convert the grams into moles using your Nessels equals M and M's formula. So we're wanting to know how many moles are in 2 grams. So we would go 2 grams over the molar mass of HCl, which we discussed in the first thing, which was 36.5 grams per mole, and the answer is 0.0548 moles. So now we can go to the cats equals knocked over vases at 1 and work it out. So we're going to put the number of moles in here, so that's 0.0548 divided by the volume, which is 0.05, as we discussed on the previous slide, and when we put that in our calculator we get 1.10 moles per litre. Okay, easy peasy. You can go ahead and do that.